Hello, everyone, and welcome to another wonderful day of chemistry. So today we're going to be looking at coordination complex structure. So what we're going to do is take these coordination compounds and try and frame them in a three-dimensional view. And it turns out that we're going to find that a lot of these complexes are going to be brighter, more colorful, and a lot more fun. So one of the first things to note is that I may have a single molecular structure that can actually adopt different geometries, which can have much different functions. So a good example of this is going to be one of our favorite platinum compounds, diamine dichloridoplatinum, also known by its common name as platinum. Now, platinum is a fun drug that has very strong anti-cancer activities. But the issue is there's two different ways we can arrange these chlorines and these amines. So we can have the chlorines either on the same side or on opposite sides. And these are going to be referred to as geometric isomers. And this will mean that they'll interact with their environment very greatly. And this usually happens anytime you've got two of a single ligand. Either they combine next to each other or opposite. Now, if these ligands are on the same side, they're denoted with the cis prefix. So in this case, we have cisplatin because both the chlorines are on the same side, which means so are the amines. Or if they're on opposite sides, this means that they're trans. So in this case, transplatin denotes these two chlorines are on opposite sides. So cisplatin actually turns out to be a very powerful anti-cancer drug, has one of the better, more general efficacies. Transplatin, well, it works, but not really. And so if you have different potential arrangements of your ligands, you can have very different types of chemistry that you do. And we've actually seen one of these in labs, looking at a cobalt complex. So it turns out most of our cobalt chlorine complexes can also adopt this similar structure. So if we look at tetramine dichlorido-cobalt, one of the cool things is if the chlorines are on the same side, we generate a cis structure. And again, this works because we only have two chlorines. Doesn't matter what else is bound, but because I've got those two chlorines, I can denote the whole structure based on it being cis or trans. These are going to be the only two possible ways I can arrange two chlorines around a center. Now, the cis cobalt is a beautiful purple, and the trans has that much more magnificent green that we saw in lab. So we started by having a trans dicobalt bis ethylene diamine structure. And we went from green in the trans structures to a purple cis arrangement. And so this is a very cool feature. Different arrangements, different names, different chemistry, different colors. Now, this cis-trans terminology works if we have two different ligands. But what happens if I've got three? So if I've got three monodentate ligands, I can define the structure based on their relationship to one another. And this occurs in two big features. So if all three of those ligands are on a similar face of the molecule, it's called a FAC arrangement. So this would be a FAC ethylene triamine trichlorido cobalt 3 complex. And it would look like this. The cobalts are all on one side and the amines all on the other face. However, this isn't the other potential arrangement. You could imagine moving this chlorine over to the other side. In this case, we have the Mayer arrangement. So I move this chlorine over here, and all three chlorines are along a meridian, so a single plane. So think about things like the prime meridian is the line that cuts through the whole Earth along a single plane. So we have the amines all along one plane and the chlorines all along the other. And so we see this various arrangement. FAC for a face, Mayer for a side, cis if we've got two ligands on the same side, and trans if they're on opposite. all of these different arrangements lead to different structures, can lead to very different chemistry. So if you need to go ahead and pull a drug that is a metal coordination complex, make sure you pay attention to what the prefix is. Fac and mer makes a big difference. So next time, we're going to look at how these coordination complexes are formed and what this means about their chemistry. Until then, take care.